Hi, welcome back to my channel. Today we are going to talk about Kafka streams. So Kafka is a broker architecture based distributed messaging engine which exposed different set of APIs to consume the data from the broker. So one was high level API, the other way is the Kafka streams. If we go little bit of a different technology like a Spring ecosystem, if we use Spring Cloud Stream, we can use and consume. So here today we are going to talk about Kafka streams. What is Kafka stream and how Kafka streams is used to develop a simple application, and how do we able to do the aggregation, and what variety of the windowing functions can be utilized when we are getting the data from the broker. Okay, if you want to know more about the details, you can visit these two links, and there will be a code available in the GitHub repository with Kafka streams. Thank you. So this is Kafka streams. So here I'm considering a simple use case, developing a simple application. I'm going to send a message, and that message being processed, and then after processed, I wanted to print that data, how many times the message words are occurred, uh, which inputted from the console, and also we can send that output back to the another new Kafka topic. Okay, this is all about the use case. So Kafka streams quite different from the high level API. That means you will be keep receiving the data, and you can manage and maintain state of your object by using the Kafka streams. So that means even though your Kafka broker is up and running, say my consumer is down, the Kafka stream consumer is down, do I able to get the state of the previous data? Yes, of course you can get it. What it happens is it stores underneath a KSQL as a local storage. Until you clean up that storage, it won't go away. That's how the Kafka streams was designed. Because on failures, if you want to see the previous data content, yes, definitely you can go ahead and track it. And Kafka streams, it uses a topology concept. Topology nothing but you stream the input from the Kafka broker. After streaming, you can do the different types of transformation, like get the key and value from the Kafka broker, whatever the message was published on that specific topic. After that, you wanted to build chain of activities. As I was talking, you can also apply within this particular window time. If you want to receive a notification, you can receive that message and you can calculate. If it is going beyond that, you can ignore it simply. So that's kind of a mechanism which supports. So these are all called topology. Will build the topology will be further decomposed into subtopologies. We can see all those things in real time, and and it will be keep listening on the messaging system side, and as soon as message arrive to the broker on a specific topic, the Kafka stream consumes it and does as per the topology logic, and and it prints on the console or it streams out to. You can build here stream to Kafka table to again stream, like vice versa. This kind of a fundamentals are being used to build the real-time application use cases. So this is a very high level Kafka broker architecture. So producer who produces a message on the broker into a specific topic, and that topic data will be consumed by independent consumers, or consumers are placed into the group. So that is how this architecture works. So broker can be placed into the cluster. So one of the broker become the leader, the other brokers become the followers. If one of the broker was down, there will be a zookeeper, another set of services, which is a coordinator service, which brings up one of the follower to leader. That is automatically does it. We don't need to do it manually from the admin standpoint of view. That's all about Kafka. If you'd like to know more about Kafka details, you can definitely visit kafka.apache.org and you can go through the documents. Let's move to next slide. So this is a physical architecture in my particular use case, which I'm doing it. So I have a console producer where I'm going to input some information. That information sent to the broker. Broker is running on 9092 port, and I'm writing a Kafka Streams application. So that is a Java consumer. So where we can see the aggregation data over the console and servers up and running. Yeah, as I said, if you have the already running Kafka broker, yes, it's well and good. If not, you can bring up your local Kafka broker, or if you want to implement through Docker or Docker Compare base, you need to have the respective softwares and use it, and then bring up the Kafka. The testing scenarios, as I said, console producer we use, and Java consumer we use for the looking at the data. So prerequisite softwares are specified here. You can go with Java 8 because Java 8 features based Kafka streams more evolved. So that's the reason I'm recommending here. And Docker Compose, if it is required in your particular case, that is depends on your local environment. And IntelliJ IDE or Eclipse. And Kafka Streams is the library which we need to download it from the Maven repository, because here I'm using Maven is the build tool, and Docker Compose YAML to bring up local broker and bring down the local broker, and internet connectivity because I'm downloading the broker Docker image from the internet. That's the reason I use internet. If you have locally running, you don't need to do it. The intended audience are Java developers, medium to high skill set, and Java architects. So Kafka Streams also supports, as I was telling, windowing function. That means, say, a sliding window. If I am specifying a sliding window, say slide 2, 5, every 5 seconds, within 2 seconds, there will be a slide. Within that time window, if I am receiving the data, yes, I can get it. If not, I will lose that data. And time window, I will have a time. Within that time, I can get the message, then I'll consume it. Tumbling window. So tumbling window will have say 10 seconds, for example. If I'm specifying within the 10 seconds in that tumbling window, if we are getting the data, we'll consider. Otherwise, we lose that data. So such scenarios where we can build applications. If you want to know, please refer the documents about the Kafka streams by following the windowing operation concepts. And also Kafka stream, say you are getting data on one stream, say you are getting data in another stream. Based on that, you want to do like a employee department mapping, such kind of a thing which we usually build application in database terminologies. The same thing also where we can get it, say two data sets when we are getting, and if you can specify the windowing function for the both the functions, and if we get the data, you can do a joining. And aggregation also you can definitely perform like counting, averaging, minimum, or whatever the features which is supporting from the K-stream library, because these libraries keep evolving, we can definitely use it. And this data, as I said, we represent as a K-stream. K-stream can be converted into K-table, like it looks like a table data structure where you can see like your data organized in the table fashion. Say that you want to again stream from table to K stream. Yes, you can apply. That is also we can able to see it. These are the reference URLs, and there is a Git library where you can download the code and test it in your local. Thank you. Happy learning. Now let's go to the real-time coding. Yeah, you can see that this is the simple consumer where I am using Spring, sorry, the Kafka Streams library which I am using it. This is the dependency where we need to have Kafka Streams and Kafka Client. These are the two libraries which is being used to build this application. So here is the code. So you can definitely refer a README file. It will give you how to install confluent Kafka in your local broker if you wanted to, and there are certain Kafka help material, how to create topic, and how to do some lookups and all those things. So let's go ahead and analyze the code. So here we are using streams config is the name of the configuration parameter keys which already defined it. We don't want to duplicate, so I'm referring as is. We need to specify application ID and client ID. Where is my server is running? So I am saying that localhost 9092, the broker service. What is the serialization class I wanted to use to pass my key and value, and whether I want the Kafka offsets. I want earliest, I want latest, depends on your application use case. You can go ahead and configure. Time being, here I have configured earliest. That means from the beginning of the message, whenever my consumer starts up. So whatever it is available in the local store, I can I can fetch it. That's how I have written in this particular. So I was talking that in the PPT, building a topology. So here, this is the code. How do we able to build the topology? So we need to construct a streams builder. So we need to use those configuration parameters, apply a streams builder. So streams builder will give you an object. That object we have to specify where is my input topic name which I am going to consume. So you can specify here. So this is called a input stream. So this object will give me a case stream object of key and value, both are string type. So I'm just putting some sys outlines what is happening to understand. So this is what I was talking. Input dot flat map values I am using as a library. You can use various you know uh, methods available, depends on your use case level. So I am getting initially values. That value I am considering the actual key value of your Kafka broker, that I am applying with a split logic. I wanted to count on a word. If the same word is occurring more than once, I wanted to do aggregation. So this is what I was talking there. Count, group by, these are the SQL kind of a libraries which is supporting even the Kafka streams. That's the beauty of this. And I'm just trying to see what is the key here. Definitely I'm not sending the key as value, so that's where I can see that null when I run my code, and value I'll get the real values. And then I am creating a count, and that count I am materializing nothing but keep changing. Say CDC, change data capture. CDC is the fundamental. That means there is a content keep changing on that particular, it gets updated. So that is a materialized view, and that represented as a k table. That's what I was represented in the PPT. K stream to k table, k table to k stream, we can do both the ways. So again, what I'm doing is it gives me a k table. K table again I'm converting into a two stream. So I'm saying that as a count stream. So now I wanted to print how many words occurred on that particular word. So I'm printing that onto the console. Say that I wanted to send it to my output topic. Yes, definitely I can do it. I can do a stream out. So count stream. This is the output topic name, and how does it the key value pairs again look like for the output topic? So here I am saying produced with serialization is key, and value is long. So a hello to, for example, ABC comma 1, for example, like that, I'll send it. After constructing, I specify builder. Builder is basically a streams builder. Builder.build. This will give me the topology. This is the topology which I was referring in the document. This topology further decomposed into multiple topologies, because here I am writing, uh, referring the data, getting the data and doing some count store. This is the local intermediate store which has the data previously if we started. If not, if it's a fresh consumer, we will get only the fresh data. So this I'm just putting for my representation purpose. And what I do is I construct a Kafka Streams object by following the configuration and the topology. So we can see it. So we receive it now, Kafka Stream, and in case of uh, improper shutdowns, I wanted to make sure that the Kafka stream shuts down appropriately by following the shutdown hooks. This is a real-time people can write this kind of code. Normal developers cannot aware of these fundamentals. You can study more if you want to know what is a shutdown hook. Say that, as I said, if my consumer keep shutting down, I don't want to see the old content, then you can submit some arguments and you can clean up old data. Otherwise you don't need to do it. Just this is a tip which I have written. And then we need to start the real Kafka stream. Let's come here and see what is here. So here I am using a lock, because whenever first time the Kafka engine is being starting, so I wanted to manage and maintain. So Kafka has these streams will work on the thread basis. Any request, I mean to say request means here the message is arriving, which is handling on the per thread basis, which will handle it. Say that if we don't write this kind of a code, what happens if a particular thread is dead, the overall your consumer is dead. Once consumer is dead, you will not able to bring up, and then you have to work a lot of night shifts or something like in the real time. So to effectively handle my streaming application, I'm setting what was the old state and what is the new state. If my new state is up and running and my old state becoming rebalancing of the threads, which internally happens when it is receiving a lot of data from the Kafka broker engine. So that time I wanted to effectively handle it. So I put this condition and latch. So I am saying that, okay, once this state is this way, that means the old state should be rebalancing state and new state should be running. Then I wanted to start my process when it is being initially started, or in case of any failures as well. Then I do apply a Kafka stream start. So once I start the Kafka stream, it starts a long running process, and I wanted to wait until I supposed to kill or kill by itself due to some reasons. So this is all about the fundamental. Now I have a console producer I was talking about. So I'm going to use console producer. So I have a Unix box running in my local system. I'm just saying hello test. I'm sending a first message to my broker. Now I have not started my engine. I'm going to start my Kafka engine of consumer type. Now you can see that, as I was referring to you, that it is going to start a build stream and the topology. This is called topology. So main topology is decomposed into subtopology 0 and receiving on the input topic, and then I am using a intermediate processor for processing all of my topology, that is stores. I am using it. In this particular case there is no store because I'm just using a flat map based. That's the reason. Here it is like a database kind of a select, and then it is being processed. Whatever the logic has been implemented. These are all internally constructs by the KStream library. We don't need to do it. We have to just think and build a logic that internally considers it, and where to sync my results. So that is a sync. That means source, process, and then sync it. So these are the three keywords also you need to understand. So processor is nothing but doing all of your job. Sync is nothing but where is the target I need to place it. Source means where I am receiving from. So after doing some kind of aggregation, what I am doing is I am creating a count store. So if you look at it in the code, in the topology, I am specifying count store here. So that's why it is creating a sync in the file system at the broker end, and then filtering it. Then it is getting another subtopology and count store. It is retrieving from there and doing aggregation and then syncing to the target. So to k table to k stream, it is being doing it. Okay, so this is all about it is printing. Now also you can see the states, old state, new state. So it is balancing all those things, evaluations done. So I have sent hello test. So hello occurred one time, test occurred one time. Let me go ahead and put hello test 2. Now I can see that this is one of the L is missing. Now I see that hello and test is one time. If I type hello test as message as the first, now I can see the aggregations. It will take a little while to do the aggregation, and it will print it on the console. Yeah, now you can see hello has been printed 2 times, test was printed 2 times. So that means it is collecting whatever the old data was arrived with the aggregation count of those words which will be receiving. So that's how this works as an incremental fashion. That's what I said. It is a materialized view. The changes would be captured, and the same data also I am sending to the output. In the topology I have specified send it to output stream. So here now we can come and see, due to some reasons this is not printing. I'm using Apache Kafka, but if I kill the consumer, I can see that total consumer messages are 6, because if you look at here, I have sent 6 messages as a split voice. So hello test 2, hello test 2 is 2, hello test. So overall, but due to some technical glitch which is not displaying here, but if you look at it really at the broker end, it is like 6 messages, but you will see in the same fashion as displayed in the console. But there it will display all including test 2. But in this particular case, uh, in the console we can see the materialistic change, but I'm not sure what went wrong here suddenly. So that's what I'm trying to understand, but definitely it has been reached the Kafka. So the source code is also available in the Git repository. So you can go ahead and visit the Git repository, and there is a readme file. You can study this, and then you can experiment Kafka streaming. If you are interested, please go ahead and subscribe, like, whatever you wanted to do it. Please do it. Thanks for watching my video.